addition to being an integral part of engineering education and providing our students with invaluable experiential learning, our mechanical engineering labs are the beating heart of LAU's research enterprise. Engineering faculty and graduate students are using these state-of-the-art facilities to conduct cutting-edge applied research that improves the human condition.
In this lab, we have a subsonic open-loop wind tunnel, which can be used to develop efficient wind energy technologies, and this can significantly help us address the energy crisis nowadays. We are currently testing a wind turbine in this lab in order to optimize its blade characteristics for better performance. In this way, we can minimize the cost of producing energy from wind. This wind tunnel is equipped with PIV measurement tools, which can be used to obtain point-by-point details of the flow. By analyzing successive images of seeding particles that are traveling with the airflow, we can obtain the velocity at various points in the wake region behind the turbine. And this can be used to validate our simulation results. Without such powerful experimental tools, simulation results will remain theoretical and unvalidated. And that's why we need to couple simulations with experimental results for better accuracy. With the help of this wind tunnel, our graduate students are conducting experiments with high accuracy and publishing their results in top journals. In our experimental fluid mechanics lab, we have cutting-edge technologies that can help us characterize flows around various objects. In this water channel, for example, we can circulate a huge flow rate of around 150 liters per second, place various objects in the test section, and test forces around these objects. This process can help us optimize the shape of the objects in order, for example, to reduce the drag around them or to increase the lift forces around them. The water channel can be used for both educational and research purposes. It is also equipped with PIV measurement tools, where point-by-point details in the flow can be characterized.
In addition to the research being done here in the makerspace, we also provide an environment for graduate students and researchers from different fields where they can produce or manufacture different parts or their products, their prototypes, using mainly additive manufacturing. So we have 8 3D printers that can handle different materials and different dimensions. The makerspace is also equipped with all the necessary tools and instruments that researchers can use to assemble their parts or even to test their prototypes.
What you see here is the manufacturing lab. It's state-of-the-art equipment. We have several CNC machines. Some of them are 5-axis machines. The beauty of these machines is that they allow you to design pretty much anything you want. You can fabricate whatever you draw on a PC, and then you can send it straight away to the machines. We can design new materials, we can test materials. Students, even graduate students, can use these machines at all times throughout the day, which is quite exciting. For graduate students specifically, these machines are very exciting. First of all, the fact that you have a 5-axis CNC machine allows students to fabricate really complex parts and then use them in the research projects. And that would mean not just for mechanicals, it's all abroad the school entirely. So students from mechatronics, mechanical, industrial, computer, electrical, anything that needs making, that's very complex, that goes into hardware, we can do it here. In terms of the impact post-graduation for these students, some of our students go into PhDs in research and some go into the industry. If we're talking about the industry, what they do here in the manufacturing lab translates directly into the industry. So manufacturing, designing, 3D printing, making stuff from scratch, building intricate, delicate models, those are skills that are hard to do, hard to mold, but once they have them, that's immediately transferable. In terms of research, students can research materials themselves. So the research papers themselves can be these materials, these products that they're doing. That's one kind of PhD. Another would be using whatever they build here as part of something bigger.
In the manufacturing lab, we are focused on surface and surface engineering. Why? Because we know that most problems starts at the surface. So if we have wear, if we want to study a new coating, if we want to study a hydrophobic surface, everything has to be really focused on the surface. We have unique equipment that is available in the Middle East to study the surfaces at the micro and nano scale. So using SEM, EDS, also optical equipment like interferometry and confocal technology allows the students to really study surfaces at a very, very low scale. So this allows us to have unique research and unique contribution to knowledge. More and more new industries are looking into specialized graduates where they have an added value. Our new equipment allows the student to analyze and get information about the surfaces at the micro and nano scale. Having this information allows them to have an edge over the others because they have the possibilities to do research and to publish. And this will be later a door opener for them to go into those specific high-end industries.
From fine-tuning of wind turbine designs to validation of delta wings, our faculty and students are taking part in the excitement of creating the miracles of the modern age.